So today let's discuss the remaining questions of Lagrange's multiplier method, and we'll try to wind up this topic in this video itself. So let's see the next question. So this question says that using Lagrange's multiplier method, show that rectangular solid of maximum volume which can be inscribed in a sphere is a cube. So we are supposed to show that let's say this is a sphere and a cuboid is a rectangular, a solid is basically inscribed inside it. So for example, let's assume that this is a rectangular solid, let's say somewhat like this. So we are supposed to show that this rectangular solid, for this to have a maximum volume, this rectangular solid must be a cube basically. So let us assume that let x, y and z be length, breadth and height of rectangular solid. And it is given to us that we are supposed to maximize its volume. So volume of this rectangular solid will be basically x, y into z. So we are supposed to maximize this volume and we are given a sphere. So let us assume that x square plus y square plus z square is equals to r square be the equation of sphere. So it is a sphere with center 0, 0, 0 and radius as r. So these are the information that are given to us. Now we are supposed to maximize this volume provided this is inscribed inside the sphere given with this equation. So let us write our function f. So that will be x, y, z plus lambda times x square plus y square plus z square minus r square. Here lambda is basically our Lagrange's multiplier. So if we take its double total derivative, so that will be basically yz plus 2x lambda into dx plus xz plus 2y lambda into dy plus xy plus 2z lambda into dz. Now to get the possible critical values, so let's just equate the total derivative with 0. So that basically gives us yz plus 2x lambda equals to 0 and xz plus 2y lambda equals to 0 and xy plus 2z lambda equals to 0. Now we're supposed to solve these solve these equations basically to derive out some information. So let's name these equations as 1, 2 and 3. Now what I can do is I can just subtract basically equation 1 from equation 2. So let's see what we get. So if we subtract it, we'll get xz minus yz plus 2 lambda into y minus x equals to 0. So that basically gives me, I can pull out z from these terms. So if I do so, I'll get z into x minus y plus, I can pull out negative from this bracket. So I'll get minus of 2 lambda into x minus y equals to 0. So from here I get x minus y into z minus 2 lambda equals to 0. So this basically gives me either my x is equals to y or my z is equals to 2 lambda. So these are the information that I got from here. Now let's solve it further. Let's subtract equation 2 from equation 3. So if we do so, let's see what we get. So we're left with xy minus xz plus 2 lambda into z minus y equals to 0. So if I pull out x from these two terms, so I'll get y minus z. Likewise, to make here y minus z, I can pull out negative sign from here. So I'll be left in minus 2 lambda into y minus z equals to 0. So from here I got x minus 2 lambda into y minus z equals to 0. So this basically gives me either my y is equals to z or my x is equals to 2 lambda. So these are the information that we have so far. So let's solve them one by one. So case 1, let us assume that my x is equals to y. So if I just substitute this x equals to y in equation 1, so I'll get y into z plus 2y lambda equals to 0. Now I can just pull out y from the whole equation. So I'll be left with z plus 2 lambda equals to 0. So that basically gives me either my y is equals to 0 or my z is equals to minus of 2 lambda. Yeah, so if my y is 0, then my x is 0, and if my both y and x are 0, then from using equation 2 or 3 I can conclude that my z is also 0. So that basically, that doesn't lead me anywhere. So let us assume if we take z is equals to minus of 2 lambda, then let's see what we get from this. So if I take z is equals to 2 lambda minus of 2 lambda, so that basically leads me to this term again, that is y is equals to x. So from here I got my x is equals to y. Likewise, if I solve these relations, I'll be left with y is equals to z. So let's name this as equation 4 and let's name it as equation 5. Now using 4 and 5, so what I'll get is x is equals to y is equals to z. So this basically shows that basically the length, width and height of the rectangular solid that's inscribed in the sphere is same. So it basically shows that that rectangular solid is basically a cube. Now we are supposed to calculate its volume as well. So for that we need to find out what will be basically the length of the cube basically. So we have this relation that is basically the equation of sphere. So using that, if I put x equals to y equals to z, so I'll get 3x square equals to r square. So from here I'll get x square equals to r square by 3. So this basically gives me x equals to r by under root 3. I've just excluded that negative sign because length cannot be negative, so I'll take my x as r under root 3. Likewise, since my x is equals to y equals to z, so all these three lengths will be equals to r by root 3. So from here I'll get my a volume of the cube as r cube by 3 root 3. So this is the maximum volume of the rectangular solid that can be inscribed in a sphere, and that rectangular solid is basically a cuboid. So let's move on to the next question. So the next question says that find the extreme values of this function such that this and this condition holds. So let us write the function capital F. So that will be 2x plus 3y plus z, basically the function whose value we are supposed to maximize or minimize, subject to the condition 1, that is x square plus y square minus 5, plus condition 2, that is x plus z minus 1. So here basically my lambda 1 and lambda 2 are Lagranges multiplier. So let's take its total derivative and see what we get. So we'll be left with 2 plus 2x lambda 1 plus lambda 2 into dx plus 3 plus 2y lambda 1 into dy plus 1 plus lambda 2 into dz. Now if I equate the total derivative with equals to 0, so I'll get three relations, that is 2 plus 2x lambda 1 plus lambda 2 equals to 0, 3 plus 2y lambda 1 equals to 0, and 1 plus lambda 2 equals to 0. So if I solve these, so I'll basically from this equation, so I'll basically get lambda 2 is equals to minus of 1. Let's name it as star. Now if I just substitute this value of lambda 2 in, let's name it as 1 2. So if I just substitute value of lambda 2 in equation 1 using lambda 2 in equation 1, so what I'll get is 2 plus 2x lambda 1 minus 1 equals to 0. Now from here I can just use it to find value of x in terms of lambda 1, so that will be basically x equals to minus 1 by 2 lambda 1. Likewise, using relation to equation 2, I can write y in terms of lambda 1, that will be minus 3 by 2 lambda 1. So I got x and y as these, and my lambda 2 is basically minus 1. Now I have a relation in x and y, basically equation, that is x square plus y square equals to 5, and I have parametric values of x and y in terms of lambda 1. Then I can use these three terms to get value of lambda 1. So let's do that. So that will be x square plus y square equals to 5. So if I take x square, I'll be left with 1 by 4 lambda 1 square, and from y square I'll be left with 9 square into 4 lambda 1 square equals to 5. So if I simplify it, I'll get 10 equals to 5 into 4 lambda 1 square. So this basically gives me lambda 1 square equals to 1 by 2. So from here I'll get my lambda 1 as plus minus 1 by root 2. Let's name this as star 2. So this will basically give me two values of x and y. So when my lambda 1 is basically 1 by root 2, then my x will be minus 1 by root 2 and my y will be minus 3 by root 2. And if you know, we have a relation in between x and z as well, that is z is equals to 1 minus x. So from here I'll get z equals to 1 minus x, that is 1 plus 1 by root 2. So this basically gives me root 2 plus 1 by root 2. So I got xyz, that is a point xyz as minus 1 by root 2, minus 3 by root 2 and root 2 plus 1 by root 2. So this is one of the possible points where the function f small fx can achieve extreme values, and there can be another point depending on the value of lambda 1, that is minus 1 by root 2. So if I take my lambda 1 as minus 1 by root 2, I'll get my x as 1 by root 2 and my y as 3 by root 2. Likewise, my z will be 1 minus 1 by root 2, that is root 2 minus 1 by root 2. So I got another possible point of extreme value as 1 by root 2, 3 by root 2 and root 2 minus 1 by root 2. So these are the 2 points where the function can have extreme values. So now we are supposed to see at which point it will attain maxima and which point it will attain minima. So for that we need to restore to the function second order total derivative of capital F. So let's find out what that will be. So our df is this, so d square f will be basically 2 lambda 1 into dx square plus, that's the only term with x, and if we do it with y, it will be 2 lambda 1 into dy square plus 2 plus 2x lambda 1 plus lambda 2 into d square x plus 3 plus 2y lambda 1 into d square y. Now we're supposed to just substitute in values of lambda 1, lambda 2 and xy. Basically at these two specific points to see. Let's just first simplify it. We can take 2 lambda 1 common from these. So it will be 2 lambda 1 into dx square plus dy square plus 2 plus 2x lambda 1 plus lambda 2 into d square x plus 3 plus 2y lambda 1 into d square y. Now we supposed to check basically. There will be two cases. Case 1, when my x, y, z point is basically minus 1 by root 2, minus 3 by root 2 and root 2 plus 1 by root 2. And in that case, I assumed my lambda 1 as 1 positive of 1 by root 2. So if this is the case, then d square f will be basically 2 times lambda 1, that is 1 by root 2 into dx square plus dy square plus 2 plus 2 times x, my x is minus 1 by root 2 into lambda 1, that is 1 by root 2 plus lambda 2. My lambda 2 is basically minus 1 from star. It is minus 1 into d square x plus 3 plus 2 times my values y is basically minus 3 by root 2 into lambda 1, that is minus of positive of 1 by root 2 into d square y. So if I simplify it, I'll get root 2 into dx square plus dy square plus it will be 2 minus 2 into 1 by 2 minus 1 into d square x plus 3 minus 2 into 3 by 2 into d square y. So this term will be, this 2 balances this 2 and here also. So we are left with under root 2 into dx square plus dy square plus this term will reduce to 0 and here also we'll get 0. So this is the only term we are left with and it is always greater than 0. So we can say that at xyz equals to minus 1 by root 2, minus 3 by root 2 and root 2 plus 1 by root 2, a function attains minimum value. And that value will be basically small f x y z will be, my small f function is basically 2x plus 3y plus z. So 2x plus 3y plus z. So it will be minus 2 by root 2 minus 9 by root 2 plus root 2 plus 1 by root 2. So that will be minus 11 plus root 2 plus 1 by root 2, that is root 2 minus 10 by root 2, that is 1 minus 5 root 2. So this is the minimum value of function and it is attained at this point. Now let's check for another case, that is case 2, when my x, y, z point is basically 1 by root 2, 3 by root 2, root 2 minus 1 by root 2 and in that case my lambda is basically minus 1 by root 2. So if I just check in values of d square f at this point, so that will be basically 2 lambda 1, that is minus of root 2 into d square dx square plus dy square plus 2 plus 2x lambda 1 plus lambda 2, that is 2 minus 1 plus 2 into x, that is 1 by root 2 into lambda 1, that is minus 1 by root 2 into d square x plus 3 plus 2y lambda 1 plus 2 into y, that is 3 by root 2 into lambda 1 minus 1 by root 2 into d square y. So that basically gives you minus root 2 into dx square plus dy square, and from here I'll get this basically reduced to 0 and this will also reduce to 0. So I'm left with minus root 2 into dx square plus dy square, which is less than 0. So at this point a function attains maximum value, and that value is basically f(x,y,z), and this is 2 times x, that is 1 by root 2, plus 3 times y, that is 3 by root 2, plus z, that is root 2 minus 1 by root 2. So this is 2 plus 3, 9, 11 plus root 2 minus 1 by root 2, that is 10 plus, that is 1 plus 5 root 2. So this is the maximum value, and this is the minimum value that the function small f(x,y) can attain. So let's move on to the next question. So the next question says that find the maximum value of this function subject to the conditions, subject to this condition, and here x, y and z are greater than 0. So let's write our function capital F, that will be basically x square y square z square plus lambda times x square plus y square plus z square minus c square. So our function is this, and here lambda is basically the Lagranges multiplier. So let's find out its total derivative. So that will be basically 2x y square z square plus 2x lambda into dx plus 2y x square z square plus 2y lambda into dy plus 2z into x square y square plus 2z lambda into dz. Now if I equate it with 0, basically I'll get some relation that will help us find out the condition to get critical values. So if I equate it with 0, I'll be left with 2x into y square z square plus 2x lambda equals to 0. Likewise 2y x square z square plus 2y lambda equals to 0, and 2z x square y square plus 2z lambda equals to 0. Let's name these equation as 1, 2 and 3. Now if I basically multiply equation 1 with x, equation 2 with y and equation 3 with z and just add in these equations, so I'll get basically 6 times x square y square z square plus 2 lambda into x square plus y square plus z square equals to 0. Now this is the value of the, like basically this is the function whose value we are supposed to maximize. So let's name it as u. Let u equals to x square y square z square. So this equation will be basically 3u plus lambda into x square plus y square plus z square, but x square plus y square plus z square is equals to c square using the given condition in the question. So it will be c square equals to 0. So from here I'll get my lambda as minus 3u by c square. So this is my lambda basically. Now what I'll do is I'll just substitute this value of lambda in any of the equation 1, 2 or 3 to solve it for values of x, y and z. So if I just substitute this value of lambda in equation 1, so I'll get 2x into y square z square. I can just pull out 2. So equation 1 is x into y square plus z square plus x into lambda, that is minus 3u by c square equals to 0. Now from here I'll get x into y square z square minus 3 by c square into x, and u is basically x square, y square, z square equals to 0. Now if I pull out x, y square, z square out, I'll be left with 1 minus 3 by c square equals to 0. So from here I'll get either my x equals to 0, y equals to 0, z equals to 0, or 1 minus 3c x square equals to 0. It is c square, 1 minus 3 by c square into x square. So we can easily eliminate these points like where x equals to 0, because that will basically give value of u as 0 only, and we're supposed to maximize that. So 0 is the minimum possible value that you can attain, because it is x square plus y square plus z square. Its value is always greater than 0. So for that, because of that, we can just get rid of these conditions, that is x equals to 0, y equals to z, and z equals to 0. So from here I'll get my x square as c square by 3. So that basically gives me x as plus minus c by root 3. But if you see that in the question, they have mentioned that x, y and z are strictly greater than 0. So from here I can easily say that my x is basically c by root 3. So this is basically my x. Likewise, if I just substitute this value of lambda in equation 2, I'll get my y as c by root 3. And if I just substitute this value of lambda in equation 3, I'll get my z as c by root 3 again. So I got my x, y and z as c by root 3, c by root 3 and c by root 3. So value of u here will be basically x square, y square, z square, and that will be c square by 3 into 3 into 3, that is c raised 6 by 27. So this is the maximum possible value, and we're supposed to verify this as well, that this like at this point, basically this x, y and z, we'll get this value, like we'll get the maximum value of function x square, y square, z square. So for that we need to calculate this, that is d square f, and to show that at this point basically c by root 3, c by root 3 and c by root 3 value of u will be maximum. So we are supposed to show that capital D square capital F at this point will be less than 0. So if we show that, that basically proves this. So let's see the next question. So in this question, we are supposed to determine the extreme values of this function in this region basically. So let's write the capital F function, that is basically 3x square plus 2y square minus 6x minus 4y plus lambda into 3x square plus 2y square minus 20. So if we take its total derivative, that will be 6x minus 6 plus 6 lambda x into dx plus 4y minus 4 plus 4 lambda y into dy. So from here, if I equate it with 0, I'll basically get 6x minus 6 plus 6 lambda x equals to 0, and 4y minus 4 plus 4 lambda y equals to 0. So if I just simplify these equations, I'll be left with x minus 1 plus lambda x equals to 0, and from here I'll be left with y minus 1 plus lambda y equals to 0. And from here I can just solve them for x and y. That will basically give me parametric values of x and y. So my x will be basically 1 by 1 plus lambda, and my y will be basically 1 by 1 plus lambda. And we have this relation, that is 3x square plus 2y square is equals to 20 on the boundary of this region. So that basically gives me 3 plus 2 equals to 20 into 1 plus lambda square. So if I solve it, I'll get 1 plus lambda square is equals to 1 by 4. So from here 1 plus lambda will be plus minus 1 by 2. So that basically gives me lambda is minus 1 plus minus 1 by 2. So from here lambda will be minus 3 by 2, or my lambda will be minus 1 by 2. So we got two values of lambda, and based on that we can solve it for x and y. So case 1, when my lambda is basically minus 3 by 2. So from here my 1 plus lambda will be minus 1 by 2. That basically gives me x as minus 2 and y as minus 2. Likewise, when my lambda is basically minus 1 by 2, so 1 plus lambda will be 1 by 2 only. So that basically gives me x as 2 and y as 2. So I got these two values of x and y, and we're supposed to basically determine the extreme values, like the maximum and minimum values. So for that we need to find out second order total differential of capital F. So that will be 6 plus 6 lambda into dx square plus 4 plus 4 lambda into dy square plus 6x minus 6 plus 6 lambda x, 6x minus 6 plus 6 lambda x into d square x plus 4x minus 4 plus 4 lambda y into d square y. Here it is y. Now if I just check, like we're just supposed to check this, basically the sign of this at these 2 points. So first will be case 1, when lambda is minus 3 by 2 and xy points are basically minus 2 comma minus 2. So d square f will be 6 into 1 plus lambda, that is 6 into minus 1 by 2 into dx square plus 4 into 1 plus lambda, that is 4 into minus 1 by 2 into dy square plus 6x, that is minus 12 minus 6 plus 6 into x, that is minus 2 into lambda, that is minus 3 by 2 into d square x plus 4 into y, that is minus 2 minus 4 plus 4 into lambda, that is minus 3 by 2 into y. So that is d square y. So from here I'll get minus 3 into dx whole square minus 2 into dy square plus this term will be minus 18 plus 18 into d square x plus here we'll left with 12 plus 12. It will be minus 12 plus 12 into d square y. So this term reduces to 0 and this term also reduces to 0. So in case 1, d square capital F is minus 3 into dx square plus minus 2 into dy square, and this is less than 0. So at this point, that is minus 2 comma minus 2, thus function small x comma y attains maximum value. Likewise, and the value will be basically small f minus 2 comma minus 2, that is 3 into minus 2 square plus 2 into minus 2 square minus 6 into minus 2 and minus 4 into minus 2. So from here I'll get 4 3s are 12 plus 4 2s are 8 plus 12 plus 8, that is 40. So basically 40 is the maximum value, and let's see what will be the minimum value. So case 2, when lambda equals to minus 1 by 2, so d square f will be, and xy points in this case are 2 comma 2, so d square f will be 6 into 1 plus lambda, that is 1 by 2 into dx square plus 4 into 1 plus lambda, that is 1 by 2 into dy square plus 6x, that is 12 minus 6 plus 6 into lambda, that is minus 1 by 2 into x, that is 2 into d square x plus 4 2s are 8 minus 4 plus 4 into minus 1 by 2 into y, that is 2, that is d square y. So if I just simplify it, I'll get 3 into dx square plus 2 into dy square plus 12 minus 6 6 minus 6 into d square x plus 4 minus 4 into d square y, and this term is 0 and this term also reduces to 0. So we are left with 3 into dx square plus 2 into dy square, and this thing is greater than 0. So at this point, that is 2 comma 2, my function small f attains minimum value, and that value will be f2 comma 2 3 into 2 square plus 2 into 2 square minus 6 into 2 minus 4 into 2, that is 4 3s are 12 plus 4 2s are 8 minus 12 minus 8, that is 0. So 0 is basically the minimum value. So let's move on to the next question. So the next question says that show that the maximum rectangle inscribed in a circle is a square. And if you observe that earlier they have asked that show that the maximum rectangular solid that can be inscribed in a sphere is basically a cube. In this case they have just asked to show that it is a square. So this is basically a kind of repeated question, and that question that is in 3D and here it is in 2D. So basically let us assume that x comma y be length and width of the rectangle inscribed in given circle. So area of rectangle will be basically x into y, and let us assume that given equation of circle be x square plus y square equals to r square, where basically it is a circle with center 0 comma 0 and its radius is r. So if we write capital function fx, that will be xy plus lambda into x square plus y square minus r square. So if I just take its differential with respect, like if I take its total derivative, that will be y plus 2 lambda x into dx plus x plus 2 lambda y into dy. Now if I just equate it with 0, so I'll get basically y plus 2 lambda x equals to 0 and x plus 2 lambda y equals to 0. So from here if I solve it, basically I'll get 2 lambda equals to minus y by x from equation 1, and from equation 2 I'll get my 2 lambda as minus x by y. Now if I just equate in these two values of 2 lambda, I'll get minus y by x equals to minus x by y. That basically gives me y square equals to x square. So from here I'll get my y as plus minus x. So this is the relation basically, and we have this relation that is x square plus y square equals to r square. So if I just substitute value of y here, so I'll get x square plus x square equals to r square. So from here I'll get x square equals to r square by 2. That basically gives me x as r by root 2. I'm taking only positive value because length cannot be negative. So that basically gives me y as r by root 2. Here also I have eliminated the negative value. So these are basically the values of x and y, and if you see that the values of x and y are basically same, so this shows that this is basically a square shape only. So now to show that this is basic, like for these values of x and y, we'll get the maximum possible area of the rectangle. Let's show that d square f will be basically less than 0. So d square f will be basically 2 lambda into dx whole square plus dy whole square plus dy into dx plus dx into dy plus y plus 2 lambda x into d square x plus x plus 2 lambda y into d square y. Now we are supposed to check in this for d square f at r by root 2 comma r by root 2, and lambda is basically from here my 2 lambda is basically minus 1, so it will be minus 1 into dx square plus dy square plus 2 times dx into dy plus this term is 0 from here from 1 and this term is 0 from 2, so we got rid of these two terms, so I'm left with minus into, like I've just taken minus common from both the terms, so I'm left with minus into dx square plus dy square minus 2 dx dy. So this is minus into dx minus dy whole square, and this thing will be always less than equals to 0. So we can say that at r by root 2 comma r by root 2 a rectangle, or basically the square will have maximum area. And that area will be r by root 2 into r by root 2, that is r square by 2. Now let's move on to the next question. So the next question says that find the minimum value of x square plus y square plus z square subject to this condition. So let's do that. So here capital F function will be basically x square plus y square plus z square plus lambda times ax plus by plus cz minus p. Now if I take its total derivative, that will basically gives me 2x plus lambda a into dx plus 2y plus lambda b into dy plus 2z plus lambda c into dz. Now if I just equate it with 0 to get the critical points, so that will basically give me 2x plus lambda a equals to 0. So from here I can say that my x will be minus a lambda by 2. Likewise I'll get 2y plus lambda b equals to 0. That will give me y as minus lambda b by 2. And 2z plus lambda c equals to 0. That will give me z as minus lambda c by 2. Now I have already a given condition in x, y and z. We'll restore to that to get value of lambda. So that is ax plus by plus cz equals to p. So if I just plug in value of x, y and z, I'll get a lambda by 2 plus b into minus b lambda by 2 plus c into minus c lambda by 2 equals to p. So if I just pull out minus lambda by 2 common from this equation, I'll be left with a square plus b square plus c square equals to p. So from here my lambda will be minus 2p divided by a square plus b square plus c square. So that is basically, this is the value of lambda, and this will help us find specific values of x, y and z where function can attain extreme values. So my x will be x is basically a into minus lambda by 2, and from here minus lambda by 2 is basically p by a square plus b square plus c square. So x is ap by a square plus b square plus c square, y is bp by a square plus b square plus c square, and z is cp by a square plus b square plus c square. So this is the value of basically this is the point where function attains critical values. Now let's check in the double derivative sign. So double derivative will be basically 2 times dx square plus dy square plus dz square plus 2x plus lambda a into d square x plus 2y plus lambda b into d square z y plus 2z plus lambda c into d square z, and this and this term are 0 from these three equations, and we are left with our d square f will be basically 2 times dx square plus dy square plus dz square, and this thing will be always greater than or equals to 0. So which shows that at AP by summation a square comma BP by summation a square comma CP by summation a square, function attains basically the minimum value, and that value will be basically x square plus y square plus z square will be a square p square plus b square p square plus c square p square divided by a square plus b square plus c square whole square, that is a square plus b square plus c square into p square divided by a square plus b square plus c square whole square, and this basically gives me p square divided by a square plus b square plus c square. So this is basically the minimum value that the function x square plus y square plus z square can attain at this condition. So let's move on to the next question. So the next question says that find the minimum and maximum value of this subject to this condition. So let's see what our function f is. Our function f, capital F, we can define as x square plus y square plus z square, and subject to condition x raised 4 x square by 4 plus y square by 4 plus z square by 25 minus 1. Now if I take its total derivative, I'll get 2x plus 2x lambda by 4 into dx plus 2y plus 2y lambda by 5 into dy plus 2z plus 2z lambda by 25 into dz. Now let's just calculate its second derivative as well right now only. So that will be basically 2 plus 2 lambda by 4 into dx square plus 2 plus 2 lambda by 5 into dy square plus 2 plus 2 lambda by 25 into dz square plus 2x plus 2x lambda by 4 into d square x plus 2y plus 2y lambda by 5 into d square y plus 2z lambda by 25 into d square z. Now to check the critical points, let's equate df with 0. So that will basically give me 2x plus 2x lambda by 4 equals to 0. So from here I'll get my either my x is equals to, yeah, this is the one condition, and other condition will be basically 2y plus 2y lambda by 5 equals to 0, and another is 2z plus 2z lambda by 25 equals to 0. Now let's name these equation as basically 1, 2 and 3. Now if I just multiply equation 1 with x, equation 2 with y, and equation 3 by z, and just add in these equations, so I'll be left with 2 into x square plus y square plus z square plus 2 lambda into x square by 4 plus y square by 5 plus z square by 25 equals to 0, and this term is basically equals to 1 using the given condition in the question. So if I just substitute this, so I'll be left with 2 into, let's name this as u, so it will be 2 into u plus 2 lambda equals to 0. So from here I'll get my lambda as minus of u. So this is basically my value of lambda, and where u is basically x square plus y square plus z square, whose maximum and minimum value we are supposed to find. Now if I just substitute this value of lambda, basically this value of lambda in equation 1, so I'll get 2x into 1 minus u by 4 equals to 0. So from here I'll get x is equals to 0 or u is equals to 4. Likewise, if I substitute this value of lambda in equation 2, that will give me 2y into 1 minus u by 5 equals to 0. So from here either my y is equals to 0 or my u is equals to 5. Likewise, if I just substitute this value of lambda in equation 3rd, I'll be left with 2z into 1 minus u by 25 equals to 0. So from here my z is equals to 0 or my u is equals to 25. So we have this point x comma y comma z equals to 0 comma 0 comma 0, or you can take value as 4, 5 or 25. So from here least value is basically at this point, minimum value is at 0 comma 0 comma 0, and that will be basically 0 only, and maximum value is 25. So this is the least value of u, and this is basically the maximum value of u. Now if I just check in using the values of if I just check in the sign of d square f at this point 0 comma 0 comma 0, here lambda will also be 0. So this, like the term in second line, the one which I am highlighting with red, will always be 0, because we have calculated our conditions using this only, and this tells us that this value is 0, this and this are also 0. So we are now supposed to check for this. So at point 0 comma 0 comma 0 lambda will be 0, so we will be left with at 0 comma 0 comma 0 it will be 2 times dx square plus dy square plus dz square, and this thing will be always greater than 0. So at 0 comma 0 comma 0 a small fx will attain minimum value. Likewise, if I check for lambda equals to, basically lambda is minus u, so if I check for lambda equals to minus 4, and this term will reduce to 0, and it will be 2 into 1 minus 4 by 5 d square f at lambda equals to minus 4. It will be 2 into 1 minus 4 by 5 into dy square plus 2 into 1 minus 4 by 25 into dz square, that is 2 into 5 minus 4, that is 1 by 5 into dy square plus 2 into 25 minus 4, that is 21 by 25 into dz square. Here also it is greater than 0. Likewise at lambda equals to minus 5 we can check. So that will basically give us basically a mixed sign. We cannot tell whether, because that will be greater than, like we cannot specify using this. Here we can't say whether it's greater than 0 or less than 0. Like further investigation is needed in this case, and at lambda equals to minus of 25 it will be 2 into 1 minus 20 by 4 into dx square plus 2 into 1 minus 25 by 5 into dy square, and this thing will be 2 into 4 minus 25, that is minus 21 by 4 into dx square plus 2 into minus 20 by 5 into dy square. and this thing is always less than 0. So here at lambda equals to minus 25, small f will attain maximum value. Now let's move on to the next question. So the next question says that find the maximum and minimum value of this subject to this and this condition. So if you see that we have done its general case, like we're supposed to maximize its value with respect to condition x square by a square plus y square by b square plus z square by c square equals to 1, and another condition is lx plus my plus nz equals to 0. And herein they have just taken specific values of L, M, N and A, B and C. So what I'll do is, since I have done its general case, I'll use that general case herein to solve it for its maximum and minimum value. So we will basically get the condition as, like we basically got the condition as, like we got the condition as this. So it is L square by 1 minus AU plus M square by 1 minus BU plus N square by 1 minus CU equals to 0, where my condition are AX square plus BY square plus CZ square equals to 1 and LX plus MY plus NZ equals to 0. Now if I just compare this and this with these two conditions, I'll get my L as 1, M as 1, N as minus 1, and my A will be basically 1 by 4, B will be 1 by 5 and C will be 1 by 25. So if I just plug in these values herein to get so let's do that. Just plug in these values in equation 1. So that will give me 1 divided by 1 minus u by 4 plus 1 divided by 1 minus u by 5 plus 1 divided by 1 minus u by 25 equals to 0. So if we solve it, we'll basically get 4 by 4 minus u plus 5 by 5 minus u plus 25 by 25 minus u equals to 0. So from here, if I just take LCM, I'll be left with 4 into 5 minus u into 25 minus u plus 5 into 4 minus u into 25 minus u plus 25 into 4 minus u into 5 minus u equals to 0, and in denominator 4 minus u into 5 minus u into 25 minus u. So this basically gives me 4 into 25 into 5, that is 125 minus 30u plus u square plus 5 into 25 4s are 100 minus 24 plus 4 minus 29u plus u square plus 25 into 5 4s are 20 minus 5 minus 4 9u plus u square equals to 0. So if I just simplify it, I'll be left with 4 plus 5 plus 25 into u square plus minus u into 30 into 4 plus 29 into 5 plus 25 into 9 plus 4 into 125 plus 500 plus 500. 25 into 2 is 500 equals to 0. That basically gives us 34u square minus u into 30 into 4 120 plus 29 into 5 plus 25 into 9, that is 490 plus 125 into 4 500 plus 500 plus 500, that is 1500 equals to 0. Now I can just divide by 2 throughout, so I'll be left with 17u square minus 285 245 u plus 715 equals to 0. Now if you see that this is basically a quadratic equation in u, and I can just simplify it, solve it to get value of u, and that those two values of u will basically tell me the maximum and minimum values of u. So if I solve it, I'll be left with plus minus 245 square minus 4 into 17 into 750 divided by 2 into 17. So this basically gives me u as 245 plus minus under root 245 into 245 minus 4 into 17 into 750. This is basically 9025 divided by 34. So that basically gives us 245 plus minus under root 9025, that is 95 divided by 34, which is equals to 340 by 34 or 150 by 34. So that basically gives us either my u is equals to 10 or my u is equals to 75 by 17. So my maximum value is a maximum value of u, and here u is basically x square plus y square plus z square, so that is 10, and minimum value is 75 by 17. Now in the question you are not supposed to use this relation, you're supposed to derive it from scratch. Since we have done a general case, so that's why I just substituted its value herein. So let's move on to the next question. So the next question says that use Lagranges multiplier method to find the point on the plane this which is closest to the point 1, 0, 0. So let us assume that a point Q, that is alpha, beta, gamma, lies on the given plane. So therefore it must satisfy equation of plane. So 2 alpha plus 3 beta plus 4 gamma is equals to 5, and this point is basically closest to the point P, that is 1, 0, 0. So we are supposed to basically find a point Q such that PQ is least. So my PQ, so to minimize PQ is same thing as minimizing a square of this distance. So we have taken square just to get rid of that under root thing in the calculation. So let's define our function capital F, that will be alpha minus 1 square plus beta square plus gamma square plus lambda into 2 alpha plus 3 beta plus 4 gamma minus 5. Now if I just take its total derivative, that will be 2 alpha minus 1 plus 2 lambda into d alpha and 2 beta plus 3 lambda into d beta plus 2 gamma plus 4 lambda into d gamma. Now if I just equate it with 0, I'll get my basically value of 2 alpha as 2 lambda plus minus 2 lambda plus 2. Likewise my beta is minus 3 lambda by 2 and my gamma is minus 4 lambda by 2. Now if I just plug in values of alpha, beta and gamma in this relation, I'll be left with 2 into 1 minus lambda plus 3 into minus 3 lambda by 2 plus 4 into minus 4 lambda by 2 equals to 5. 2 minus 2 lambda minus 9 lambda by 2 minus 8 lambda equals to 5. So that simplifies to minus 10 lambda minus 9 lambda by 2 equals to 3. So if I just simplify it, I'll be left with minus 29 lambda by 2 equals to 3. That basically gives my lambda as minus 6 by 29. Yeah, my lambda is basically minus 6 by 29. So for this value of lambda, my alpha will be 1 minus lambda, that is 1 plus 6 by 29. My beta will be minus 3 by 2 into minus 6 by 29, that is 9 by 29, and my gamma is minus 2 into lambda, that is minus 6 by 29, that is 12 by 29 again. So at this point, that is 29 plus 6, 35 by 29, 9 by 29 and 12 by 29. This point is basically closest to this given point 1, 0, 0, and we can just verify it by calculating d square f. That will be 2 into d alpha square plus 2 into d beta square plus 2 into d gamma square plus 2 alpha minus 1 plus 2 lambda into d square alpha plus 2 beta plus 3 lambda into d square beta plus 2 gamma 4 lambda into d square gamma, and this and this term reduces to 0. So we are left with 2 into d alpha square plus d beta square plus d gamma square, which is greater than 0 always. So at this point Q, that is 35 by 29, 9 by 29, 12 by 29 on the given plane, point P, that is 1, 0, 0 is at least distance, and that's what we are supposed to prove in this question. So that's all for today. Thank you for watching, and we're still left with questions of Lagrange's multiplier, because there are a lot of questions on this topic. We'll see the remaining questions in the next video. Thank you for watching, and please hit the subscribe button.